Welcome to Introduction to Introductory Logic. As I said earlier, I'm going to be going through some videos talking about introductory logic, and this is the first one introducing that. So, first of all, what is logic? Logic is the science and art of reasoning well. And looking at the words in that definition, we can ask ourselves, well, what is reasoning? Reasoning is drawing proper conclusions from information we already have. And the reason logic is the science and art of reasoning well, it's a science because we are discovering the rules to apply in order to reason well. And it's an art because once we know those rules, we practice them to become skillful at them. So it's both a science and an art of being able to take the information we already have and come to proper conclusions about those things. Now, before you can even get into reasoning, you do have to assume certain things. In order to reason well, you have to at least start somewhere. And there are 3 laws of thought. These cannot change throughout an argument. For example, you can't start talking about one thing and then change to be talking about something else but keep the same word. You can't change a definition that you're using. You have to assume basic things and carry that through the whole time. So there's 3. One is the law of excluded middle. Now, excuse me. This law states that a statement is either true or it is false. There's no middle ground. You think of this a lot of times when people are trying to ride the fence on something. They don't want to commit one way or the other. Well, that's them being in the middle. And this law states that you can't do that. There is no middle to stand on. You're either going to say it's true or it is false. This will come out if sometimes people might say, well, we can't really know that thing. It's beyond our knowing. Or maybe it is, maybe it's not. But if you really get into maybe statements, those would still be true or false. Or someone might say, well, we can't really say. So these are instances of trying to ride that middle. But this law would state there is no middle. A statement is either true or it is false. Now, the second law of thought that you have to assume in order to reason well, come to proper conclusions about information we know, is the law of identity. Now, this law states if a statement is true, it is true. This seems pretty obvious, but it becomes less so, I think, in our culture today. I think when you start looking at nihilism and postmodernism, where definitions of words have really changed, which again comes back to reasoning well and definitions. We'll get to that later. But with the law of identity saying something is either true, if it's true, it's true, then it's true for everyone everywhere. So that's law number 2. Law number 3 is the law of non-contradiction. This law states a statement cannot be true and false. It's either true or it is false. It cannot be both. If someone tries to say that something is true and it's also false, then that's contradictory. There's a contradiction there. Now, this law is very important because without it, we could not argue for an exclusive truth, but we also would lose the possibility for all rational discourse. So this law of non-contradiction is very important. So just to recap, the 3 laws of thought. Number 1, the law of excluded middle. Any statement is either true or false. There's no middle ground. Number 2, law of identity. If a statement is true, it is true for everyone, everywhere. Again, this one can come up by saying when people say it's true for you, but it's not true for me. That would be a breaking of the law of identity. Rule number 3, the law of non-contradiction. A statement cannot be both true and false. So these are the laws of thought that in order to even get into reasoning, you have to assume. But it's also important to understand that there is some mystery in the world. While the reasoning well and reasoning, there's a level of certainty in different parts of logic and reasoning. There's also a lot of things that are a mystery, and these can be seen in things like poetry and metaphors, mutual partakings within certain parts of life, and that we see. So there's a level of those things, but that doesn't mean that there are not absolutes and that there are not certainties that can be known. And the Babylonians, Egyptians, and the Greeks both had a hand in developing reasoning, and so they were in the pursuit of what can be known, which is very counter our culture today, where a lot of the worldview of today is nothing can be known for certain, except for that's the only certainty, which would be breaking the law of non-contradiction in itself. Because, for example, it would be like saying nothing can be known for certain, and the only certainty would be that nothing is certain, which that would be a certainty and already has broken the law there. So that's just an example. So to get into logic, there are two different types of logic. There's formal logic and informal logic. Now, formal logic deals directly with the proper and improper modes of reasoning, which is what in the end of the introductory logic we'll be looking at. It's super fun. Informal logic deals with the operations of thinking that are indirectly related to reasoning. So, for example, it's kind of like this part's kind of like the groundwork. For example, it would be like the definitions of terms, and it would be taking those terms and finding relationships between that term and other terms, or finding relationships between statements. So this is informal logic. It's still very important, and you have to have it. So in the beginning of introductory logic, we look at informal terms, relationships of terms and statements, and then we move into formal, which would be the proper and improper modes of reasoning. Now, once we do the informal logic, looking at terms and relationships, we move into formal logic. There are more branches of formal logic. There's two. The first one is induction. Induction reasoning is reasoning to probable conclusions from examples or experience. Now, if you caught that, it's reasoning to probable conclusions. So induction reasoning is mostly all probability, likelihood, based on your experience. So there's never a certainty with induction reasoning, because it goes beyond the facts. It's taking a little part of a group or a category. It's taking what you've experienced within that and then applying that to the whole group of it. So that's why it's only a probability based on your experience. This is where the experimental sciences work, because it's based on their experiences and their experiments, what they conclude based on that. But because they can't be around for everything at all times, it's why it's the probability. Now, because of that, induction reasoning can either be strong or weak, depending on lots of factors. I mean, just thinking about it, it depends on how big is your experience. What about the group you're looking at? Is it a big number compared to the whole total? Is that group that you're looking at, is it even a good representation of the whole group, or are they outliers? I mean, lots of things, as we know, that can go into probabilities. So it can be strong or weak, depending. Now, we're not going to be looking at induction reasoning. What we're going to be looking at is deduction. Deduction is reasoning with certainty from premises to conclusions. Now, unlike induction, there's certainty with this one because of the way it's formatted, which we'll get into. There's rules for it. And because there's certainty, this one is not strong or weak. This one is valid or invalid. And as we'll learn through, there are rules about how you set up an argument. If they follow the rules, it's valid. If they break the rules, it's invalid. Now, with this one, a conclusion is contained within the premises, which we'll look at later. And if the premises of a valid argument are true, then you can conclude with certainty that the conclusion is also true. We'll get further into that as we go, and you'll see how all of that is true. But an argument is either valid or invalid, and the only way a conclusion can be known to be true is if the argument as a whole is valid and if the premises are true. Now, another thing that's important to keep in mind is it does not put on a truth. There's no truth value to this reasoning, unless you know the premises are true and the conclusion is true. It's valid or invalid. You can actually have a valid argument that is false. I'll give you a quick example. I'm going to give you an argument that's set up valid, but it has a false premise, which would make the whole thing false. For example, all dogs are reptiles. Jasmine is a dog, therefore Jasmine is a reptile. Obviously, we know that would be false because dogs are not reptiles, they're mammals. But if it follows all the rules, it's valid. So that's why it's important to reason well, is to be able to track, is an argument even valid, but does it also have the ability to be true based on the truth value? But that it's really cool, and you can actually catch when things are not valid or not. When people start saying things, you're like, oh, that actually breaks the rules, it's not valid. Now, there something in it might be true, but it wouldn't be, the conclusion might not be right because it doesn't follow the rules. So this is just an introduction to introductory logic, but I think it's super fun. I think especially like if you like puzzles, like this whole thing, if you can break it down and every little thing is a puzzle piece, and you're looking at this puzzle piece, does it fit into with this puzzle piece, and then it can all come together, which is why I think I like it so much. But again, this is introduction to introductory logic. Some of these concepts will be tricky and hard, but if for homeschoolers, if your kid is going through it, depending on your program, for example, I do classical conversations, they'll get this 2 more years. So introductory logic, intermediate logic, traditional logic 1, traditional logic 2, and then in geometry, a lot of, well, I don't know if a lot, but there's some geometry that even looks at reasoning, induction and deduction right out of the gate. So it's pretty cool. And as you get familiar with it, so give yourself patience. You will be learning something as you go. So yeah, this is just the introduction, and we'll get started on the next lesson at another time.